So in my previous video, we want to locate one new facility by using a rectilinear. So in this case, I'm going to use another method, which is Euclidean. And the optimization statement is minisums. And still on the same problem practice. So I have 5 retailers that should be close to the new warehouse. So I want to look at the new warehouse according to my current retailers, which consists of 5 retailers, and each retailer has specific coordinates P1, P2, P3 to P5, and then each of them has different weight. So if we use square Euclidean, it means the other name of square Euclidean is the center of gravity. So it means we want to place a new warehouse which is centralized to another destination. So each destination will be close to the new warehouse. And then for the center of gravity, or COG, we have to calculate each coordinate. Let's do for an x first. So an x will be used a formula which consists of an x coordinate in all retailers, and then just time it by its weight. For example, P1 has 1 coordinate for an x. Let's put 1 first in the bracket and then just time it by 10, which is its weight, and add 20, which belongs to P2, and its weight is 20, and times it by 20, and times it by 25. By 20. And then following by P5, which is 25 times 2 adds 20 times 3, which belongs to P4, and the last is 25 times 2, 8. 8 is an x coordinate for P5. And then just do an additions of all the calculation of all the numbers and divide it by the total weight. The total weight is 100, so we got 4.4 as a coordinate for an x. And square Euclidean is just like a simple equations and simple formula because it's easy to be calculated independently, especially for an x and y coordinates. And just do the same step as an x, but in this case we will change an x with a y. So each y coordinate will be put together in a bracket and will be times by its weight. 10 times 1 plus 20 times 2 plus 25 times 8 plus 20 times 6, and the last is 25 times 4, and divided by the total weight, which is 100, and then we got 4.7. And then the last step is finding the total weight for my new warehouse. And the coordinate for my new warehouse will be around 4.4, maybe it's around this side, and for y-axis will be 4.7, maybe is located around this side. So it means in Euclideans, the distant aisle will be just like a straight line. So if you want to reach my new warehouse, it's just like traveling in the very straight line aisle. So compared to the rectilinear one, in rectilinear we have to move just like a rigid aisle and perpendicular or orthogonal way. But for center of gravity, it's just like finding the center distance among all the retailers. And now just do for finding the total weight of the warehouse itself. It's just like implementing the Pythagoras one and then times it by its weight for each retailers. So just substitutes an x and y with the new x and y coordinates. Okay, for example, 10, P1 has 10 for the weight, and then 4.4 as a new coordinate for warehouse minus 1, which is belong to the P1 x coordinates. And then put in a bracket, do subtractions and power by 2 plus. And now do for a y side, for y coordinates, 4.7 minus 1, which belongs to a y coordinates of P1. And after we finish the subtractions, we power the number by 2, put in a bracket, and then do an additions and times by tens. Just repeat the sum action until all the retailers already identified. And then we got the total weight is 1,275. So my new warehouse should serve my all current retailers, and its weight is around these numbers.